overview of this so that you can zoom in on or anything that clicks. Then you can type in next to that faculty's name, your name on it, and then what interests you, just a few keywords. If it, let's say data science or web design or app design or anything like that on it, then I will see that Google Doc later. So I know who is interested in working with which faculty. Then I will connect you directly with those faculty, and then you go from there. So that is the intent. So again, there's quite a bit of stuff. You can interrupt me anytime. There's just few of us, so no issues. But I will try to finish it in an hour in case you have other engagement after 2:00. So as you know, we have 3 departments. So I'm going to go by departments and the faculty, research in those specific departments. Beginning with the biohealth informatics department. So this is a format I'm going to use. There will be 1 or 2 slides per faculty. Not every slide has their name on it. So the Professor Jones, she's an associate professor. Then I have either bullets or schematic of what they're doing. I will try to explain what their work in a very simple way. So you get just an idea, a feeling of what they're doing. With that, let me start with the Josette. She's a health informatics faculty. What she does is connecting health-related information or data, particularly electronic health records. You know those things. That's when you go to see a doctor, they enter stuff, all your details, and she's trying to link that kind of data with the social network data. Like, for example, we have a patient going through cancer treatment. There's a social network of cancer survivors or patients, and they post a lot of stuff, what is going on and what drug treatment they're having, their issues, and they post these things. So what her work and her team are doing is to collect those social network postings and connecting that with the EHR data, that's their clinical data, and then providing that information back to the care provider. So if you see here on the most left-hand side, this is a healthcare provider, these are the patient group, and the social media posting. Right now, there is no connection between these, so it's a gap on the top. What they're trying to create is a portal that you see on the rightmost side, and inform the care providers what the patients are talking, etc. What is involved here? Data analytics, text mining, textual data, social network, those kind of things, database related activities. So health related with the IT, all right, informatics. That is where it is. And the title is Patient-Centered Informatics. That is the work they're doing. So this is a level of coverage I give on each slide. If you want me to stop and any quick question, I can, for clarification purpose, I will. If not, I continue to move forward.
I have a question, Matthew.
Mm-hmm.
So my specialty is business. It's not health informatics, but that kind of fascinates me. Would that still be something that I could potentially get involved in without any health info classes?
Absolutely. There's a big part of this that's not in this schematic here is the health business, right?
Yes.
And so when you are done this, when you have a portal and all that, there is you can put a layer on the right-hand side on the circle where the portal and the healthcare provider, where the business connects, right? It could be business opportunities, improvement on the hospital side that will help with their business management, correct?
Okay. Yes.
So actually, our health informatics program has some courses along that line. I think it's in the graduate level, but it is there. You are absolutely right on dot. Actually, Josette has also some interest in that space too. She's doing some work.
Okay, awesome. Thank you.
Okay. This one gets into the next one, and we have few people very much into bioinformatics. This may be a little bit far away from most of our students' work. This could be very pertinent for bioinformatics related activities. So Jingwen is an assistant professor. She is doing all kinds of brain imaging and connecting that with the genomic data and disease identification, those kind of stuff. But if you look on the left side, the bullet item, it's all about data science, right? Data analytics, big data, knowledge discovery, machine learning, all that comes into play. So if you have any interest in that collective space, coding, data science, data analytics, maybe some degree of, you all take some data mining class, I think you took, or you are taking, I believe. So all that falls into this category. Even though this gets very crazy here, the big network schematic, that's a disease network. If these are all protein names associated with a particular disease, that's what you're seeing. But these are all derived from data. So you don't really need to know the bio side of things, because I worked exactly in this area for a very long time. So I had computer science people, informatics people, and biologists working with me as a team. Of course, I don't know anything about biology either, but I provide that computing architectural skill set and stuff like that. So this is what they do. But in the sense of data mining, data science, it's quite deep analytics, a good understanding of math, statistics, all that are required. That would help. Can I move on? The next one is Assistant Professor Saptarshi. He is into, again, health. These are all health. This is health people, another one. He's very much into public health, biomedical informatics, but most interestingly, he is working on kind of very much on the social side of things. He has a lot of projects going on locally and also internationally. What you're seeing on the left-hand side in the middle is an app that him and his team developed for providing training for healthcare providers. So they have projects in Africa, for example, where people from the villages are trained using technology so that these are midwives, how to train them to help with the baby delivery and all that, so that when they cannot travel to city for this training, instead they are providing this kind of digital training first, then they go into city maybe once or twice for real training. So that kind of an application. Then work on imaging. I don't know if any of you have interest in imaging. He works with the med school people on using AI techniques for identification of specific concerns in the radiology images and so forth. So it's kind of two different things, but it's all along the health side of things, right? Moving on, this is deep bio.
Actually, I had a question.
Uh-huh.
For the art, do you know anything else about the artificial radiology? So it says here individuals learning to swarm learning. So do you physically work with just the scans and kind of I was just wondering if you knew anything else about it, I guess.
So the idea here is these kind of specific regions after scanned images need to be identified. All right. So those are, and what they're trying to do is, okay, let me make it very concise here. What they do is these images that with abnormalities and those are normal are fed to the machine. Okay. Then the machine through AI algorithm is told what is abnormal and what is normal. So it's learning that, all right? Then they are using this kind of a technique to train radiologists, the new MDs who are coming for training. The machine learning will help those medical doctors or radiologists to get trained. The machine is doing that instead of humans. That's the idea here. So when the new guys get trained, they are presented with this, they identify, okay, here is an issue. Say, for example, the red spot there. There won't be a red spot there. It will be gray, right? They identify that's an issue point. Then the machine will tell, no, you're wrong or you're right. That kind of. So the machine is underneath the machine is doing all that. Again, if any interest in any of those, I will connect with the right faculty, introduce you to, and that is the whole idea of this session. I think I will skip this altogether. This is really hardcore bioinformatics. Okay, very deep into bio.
It said RNA, and I was like, oh, nope.
Yeah.
No.
Yeah. As a matter of fact, his work is all about RNA, and you hear RNA a lot these days. Moderna, Pfizer, their vaccines are all based on RNA. So this guy is doing quite a bit of work in that space. Actually, they are developing a new instant COVID testing kit, like a blood test, right? So you can put your blood drop and it says, yeah, what is your blood reading? Like that. So they're working on it. They got some funds to do it. I don't know the status. And they are putting all kinds of prep work on that. So this is very much into RNA. So I'm going to skip that unless you want me to. I wouldn't be able to say much either, but there it is. This is another hardcore bioinformatics guy. All right. So very much deep into, even though he uses machine learning, AI, and all those things, but the application is very deep into protein structures. Probably you have, maybe in your high school days, you have seen those things. What you're looking in this schematic, those are all protein structures. He's looking at, if changed, what happens, these protein structures, right? Very deep into that. Again, these guys are super researchers, but good for bioinformatics kind of people. Moving on, we have Jiapeng. He's another assistant professor. He works on text analytics or text mining, NLP, natural language processing. They all mean the same thing. You probably heard about it. You can take written text, do analysis on it. When you read a text article, a paragraph, a sentence, you can comprehend what is in it. How do you make the machine do it? This used to be my research. This is where I used to work on natural language processing. So this is what he does. But in particular, he's working on electronic health records. When you go to clinic, see a doctor, your hospital, all your lab work results are annotated in text. They write stories, right? The blood or the X-ray or the scanning, they write text along with some readings. That's an electronic health records. His work is, how do you see the one on the right-hand side, you see the second line, the left, pleural effusion. That line is coming from a doctor reading a lung, a radiology or something. That's what that is. So from a collection of such clinical notes, how do you develop text analytics algorithms to extract specific content? All right. So through the machine. So that is what text analytics, text mining in health, electronic health records. Continue. Okay. Kathy is again assistant professor, again in the health informatics area. What she does is sort of effectiveness of drugs, and what they do is a lot of mixed method research, efficacy of drugs, side effects, those kind of things. That's what they do. And using that, so if you were to ignore the middle schematic, what they do is through electronic health record data, she does the efficacy of drugs in treating a certain disease, and they collect that information, feed it back to drug developers to make the drugs better. So for that, they use mixed method research, interpersonal research, precision health, all those kind of stuff. So again, if there is any interest in the health side of things.
This question is
Mhm.
this similar to like what is it called?
Sorry, see, I cannot hear you.
Can you hear me?
Uh-huh.
Okay. Is this similar to it's something with an E. It's like
Epidemiology?
yes.
No.
No. Okay.
No, it's not. This is more like efficacy, that if I'm taking a medicine,
Mhm.
it's that effective for me. It's effective for you, but not for me.
Okay.
So that's efficacy. That's why you hear that a lot about the vaccine now. What is the efficacy of this Pfizer or Moderna, things like that? That's the data they talk about.
Thank you.
Finally, we have Gary. He is the director of the Biohealth Informatics Research Center. He doesn't do specifically research. He's a professor of practice. What he does is, Emily, this might be interesting to you. He connects students and student groups. He is a link between students and industry. Okay. So he brings students together to work on a project, and he then links them with the industry.
That's interesting.
That is interesting. Very interesting. So
Will you go a little more in depth? I'm sorry.
Yeah.
Is it not possible?
Professor of practice means, the guy, Gary, had a decades of industry experience, done, retired. And we have 3 people like that in our school. So they bring in a lot of industry experience. Lou Lenzi is another person in the.
Oh, yeah.
Okay. So Gary has experience in the health field and also in the business field. So then, a couple of years ago, he approached us. There's any opportunity for him in our school. We discussed and we thought this is fantastic, because for our students, we are informatics. We connect technology with industry. That's what we do, right? Mm-hmm. So what we have done, or he has done, and Lou Lenzi and a couple of others are creating student projects and showcasing and connecting that with the appropriate business partners.
Oh yeah, I'm definitely interested in that.
All right. So anytime you have, and you can do projects with him. We have a lot of students under him now, many groups. So it's a very nice setup. So you can get both the industry exposure, and if you're doing well, you get direct access to the industry, the business, right? So that's and also you learn quite a bit of, if you are interested in health, you learn quite a bit of health stuff. Their trick of the trade stuff with them, the students, because you are working in groups. Everything he does is group work. So this is Biohealth Informatics department and the faculty of research, primarily in the health informatics areas and in the bioinformatics area. The bottom line, they all deal with the data in one form or the other: bio data, electronic health data, text data, use machine language, AI techniques and all that at different scales and levels. Can I continue? Okay. Next, we are in the Human-Centered Computing, HCC. This is the department you are all in. The informatics program is in this department. Now, as the title suggests, this is human-centered computing, right? It's a lot about how machine and humans interact. That is this field. So that also connects with the HCI, human-computer interaction, and all that. You all took some course in that, right? I believe, as part of your program. So here, let me start with the chair, Davide Bolchini. Got a bit of work going on for the in the differentially abled people. Here we are looking at visually challenged blind people who cannot easily access the modern technology, apps and phones and stuff like that, because we use the screen a lot. Able people use the screen. So the question here is, can you bypass the screen because they cannot see? For that, they come up with gestures, hand gestures. The picture you're seeing on the top left is a student who developed this actually. He was a graduate student, Joe. Oh, this guy got an amazing job with the Google or somewhere after he graduated. A fantastic job. So what he does, what they do is, that thing on the hand, you can do different gestures in combination or in isolation, excuse me, and that will translate to typing. So you can query something instead of voice. You can, the voice, people always ask, I was involved in this too a little bit. People ask, why can't you just speak? So the visually challenged people, they have an issue speaking in the public. So in the open, you want to get some information, you don't want to talk loud on the phone because they cannot see who is around. So it's a stigma, there's an intimidation factor. So that's why they are they have come up with this. So instead of asking a query, you can use gestures to ask the same query. Okay. It involves a lot of design techniques, a lot of new technology playing with. If you are into any kind of design things, this is something interesting. Along the same line, Steve Mannheimer works on tactile symbols, tactile symbols. That's what you're looking at. This is the image reading version of Braille, right? So images are all represented using tactile with the height and shape of things so they can feel it. So there are, you can translate, especially this is important when you are studying STEM materials, chemistry, math, and all that, equations, graphs in particular, charts, geology, geography, biology, where there's a lot of images and things like that. How do you develop tactile graphs to represent so that blind and visually impaired people can be helped? So this is Steve. Again, there is all kinds of informatics stuff underneath this. Programming, database, interface design, in everything, any project you take. This is Andrew Miller. He's an assistant professor. He is into collaborative health technology. Quickly, again, if you remember Josette work, this is along that line. If you look here, understanding how caregivers collaborate and connect to help each other. Particularly, he's working on children's cancer space. How could parents of children who are suffering from cancer can come together and work together, help each other? All right, this is a support mechanism. So collaboratively designing and testing caregiving coordination tools for family resilience in the hospital. Got it? This involves, again, harvesting information, design, of course, we are in the HCI space, designing the interfaces. That is very useful, easy to use, the UX, UI, that is usability and utility of these things, all right? But with a purpose. You see, every single research in our school is with a purpose, with an application, right? So that is Andrew's work, a good piece of work. He's getting a lot of traction in this. Similarly, Lynn Dombrowski's work is, again, very interesting. You probably hear this a lot. It's labor abuse. There's she calls it stolen wages. So Again, this is funded by National Science Foundation, the same agency that's funding our scholarship, right? So this is important. This is a real big social problem. But in that, how does informatics comes into play? That's the ingenuity, the innovation. So relevant here is also how computer technology advancement are hurting low-wage jobs, and how can computing technologies can help elevate this issue or expose this issue. That's what she's working on. Specifically designing to address wage discrepancies with the low workers and worker-centered computing automation in low-wage service network. So if you want to know more about this, of course, Lynn is the right person. How she's doing this, the technology specifically, that I'm not very familiar, but she says she's designing user-centered design approach to identify opportunities. Okay. Anyone here interested in this whole design space? Because HCI faculty are all into technology and design, right? That's what HCI is. Erin Brady, again, another professor in the HCI. Her work is complements in a different way. This is people with the various challenges in mobility. How do you make a workplace accessible? So workplace accessibility for the disabled. That's what she is working on. So there is, I will skip one. Here is another one along the same line by Francesco. You must have taken classes from these people, right? You know these guys. But Francesco is teaching one of the, which one? I forgot, informatics classes, I believe. So this is embodiment of an interaction. So the correlation with the causation may lead people to assume causality when there is none, but correlation often provide precious hints to causation. So this kind of design technology is something that he is working on. It's very exciting project. A lot of support, again, funded by the National Science Foundation along the design space again. Acacia, assistant professor in HCI, is working with the elderly population. She is looking into the new smart technologies like Alexa, Siri, and all those things. How is it helping seniors at homes, and how can these devices be used effectively by aging individuals with their health, wellness, independence? Most important, independence. Independence give them a lot of confidence and keep them healthy. That's a very significant. In that context, the privacy and trust, those are all play into picture. So this is Acacia's work. Okay. Again, lots of technology in there. A little bit more elaboration, investigating older. These are real work. You can see her in the background. Investigation in older adults' expectation for interacting with the conversational assistants. That's really kind of thing, right? Alexa, all those things. So in an elderly setting, can an individual comfortably interact with this machine? To be honest with you, I turned off my Alexa. I heard that thing is capturing every conversation that's going on in my house. So I paid $140 and I shut it down. And because of some surprises that it is suggesting to me, I'm wondering, my goodness, where did that come from? Because then I came to know it's capturing all our casual conversations and synthesizing it and all those things. So where is privacy and trustworthiness? And the elderly, that's very important, yeah, right?
I was going to mention, I know at one point, I don't know if, do we get into policy at all through any of the research that our faculty have, like policy and privacy?
Yeah, actually, I'm coming to that
Okay.
in a minute. There's a faculty.
I know there was a big privacy and policy issue when it comes to like Alexas because like you mentioned they are constantly listening. So
Yeah.
whenever it comes to I remember there was a specific case that was in the news about a woman who was murdered in her house and she had an Alexa and the privacy of the data belonged to Amazon obviously.
Mhm.
So it was a very controversial court case where they were trying to battle to hear the audio because they were trying to prove her murder.
Yep.
So
Yep. Yeah.
definitely-
Same thing with the Ring video camera, like the doorbell. You heard the story that this house got robbed. There's a little girl was answering, and that was tapped into and realized the girl was alone. I don't know what the story was. There was a breach of privacy there and security, all that. But when it comes to elderly, these things can be very helpful, extremely helpful, especially with their independence and health, taking medications on time, reminders, all those kind of stuff. You can effectively use it. But the technology is also a threat and inhibition for that. So that's what this work is. It's a very, very, very important piece of work. Now we get into another side of things. It's still in the HCI, but this is more on pure data science and visualization. Kairi, you may have taken a class or two with him, at least one. This guy is working on big data. Big means really large data. And how do you visualize it? How do you make sense out of it? How do you interact with it so that you can ask questions? You can ask questions to a visual thing. This thing, this place, right? This is in our facility. This is in the part of the AVL, but we have a display wall in our facility now. So he's visualizing protein structures. That's what this is, large protein structures. So essentially making sense of data. This is very exciting. When you see data, how do you make sense of what is in there? What is in there is knowledge. Data by itself is nothing. So how do you make sense out of data, which is knowledge, in an interactive way? When you deal with a very large data in an interactive way, there are a lot of challenges, computational challenges. So that's what he is working into. You will see some of those things later in a minute. Here is another text mining person, Sunandan, another assistant professor, capturing dynamics in causal relationship. It's one of those things, from the text, this causal assertions, human can do it very easily. When you read 2 sentences, 3 sentences, we can easily make causal associations, but it's very difficult to do by a machine. Just to give you an example here on the first bullet sentence on the right side, the impact of extreme weather conditions on mental health. Weather is one entity, but mental condition, like in Seattle, we hear there's the highest rate of suicide because of weather. It rains all day, it is very gray, it's very dark, people emotionally, down, all those things. Those are causal relationship. And those appear in a lot of literature. So how do you extract such causal relationships from the text? That's what Sunandan is doing. Again, pure natural language processing, text mining. Okay, what do you need? Well, some understanding of programming skill set, database skill set would help. But you learn about big data tools, right? Large data analytics tools on the data science space. Then there is Carl McDormand. He's also a faculty associate professor in the HCI department. His work on synthetic artificial objects primarily humans, looking at the threshold between when a human-looking artifact becomes realistic and how a real human would perceive it. Am I making it clear? So when you walk by supermarkets or shopping centers, you see mannequins and all that, right? And men, women dressed and all that stuff. But you know those are artificial, right? And it doesn't mean anything to us. The question is how far that can go when it will create an eerie feeling to a human. That's what Carl has been studying for years. He coined that term as the uncanny valley, that fine space when the artificial entity become more real looking. You might have seen some Japanese robots.
It's
talking
like,
robots.
It's like with animation, when you see the animation that kind of creeps you out, and then
Exactly.
the animation that doesn't.
Exactly. When you look at something, we know it is artificial, I mean, they have placed this talking lady robot in their shopping place, mall center in Japan. Oh my gosh, you cannot tell that it's a real or not. And it could answer a question, it's having a conversation. And the minute one would realize this is not a real, there's that eerie feeling, So that's what he's studying. He has been, the structural models among realism, inconsistency, realism, familiarity, eeriness, and warmth, that whole space, that's what his research is centered on that. Finally, we have Joe DeFazio working on game design. Game is a big deal in our school, right? The media program, we have quite a few people, not just DeFazio. We have Zeb and Travis, and all those people are into game. In Joe's case, he's working a lot on the game. By the way, the game doesn't have to be just for shooting, that kind of game. Games are also used for health education purposes, training, that kind of things too. It can be coined as a game. So that's what Joe does in terms of health kind of applications. So this is an example of his game design for some other health applications also. Now we get into, that was HCC, that's quite a few people. Now we get into the library information science. Angela Murillo, assistant professor. A common theme in library information science is primarily centered on data management, scientific data management, organizing it, reusing it, publishing it, preserving it, right? This is real. Preservation, archiving, and long-term storage. No one pays much attention to it. What if something happens? What would happen to this data? How do you preserve and archive digital data? We are talking about digital data. So, when you are talking about terabytes of data, is there an efficient, effective way to annotate or archive? How do you go about it? So that's a big challenge. It doesn't matter what data it comes from, engineering, medicine, politics, geology, doesn't matter what data it is. It doesn't matter. So Angela's work is centered on that. We have one more person in that area, but that's coming up. Now, your question on security, is Kyle Jones. His work is on that aspect. Even though he talks about student privacy and all in education, but this can be applicable. So learning analytics is the measurement, collection, analysis, reporting of data about learners and their context for the purpose of understanding and optimizing learning and environments when it occurs. This is beautiful, right? If you take any context, that's what happens. So this involves data collection, aggregation, analysis, and drive interventions, everything. Here's the two questions. Where is privacy and where is ethics? Right? That's what we were talking about. So access, control, use, and consent, autonomy, justice, fairness, and transparency. So whether it is Alexa or it's Siri or if it is anything else, we collect data from you guys, right? So many surveys are pushed to you guys to collect data. Why? Well, we want to drive intervention, right? Of course, with the good intentions, we want to improve upon what we are doing, et cetera, et cetera. But, these kind of things, how we are using that data. In our case, we have, at least in Indiana University, we had to follow strict protocol. Everything we do, it has to be approved and sanctioned. And they tell us, yes, you can do it this way or that way. LaJoy can attest to that. Everything. We had to go through the protocol. Of course, I'm sure Alexa, Siri, and all had that, but businesses have a different way of doing things. In that 100-page fine print, they have printed that, and who reads it, right? Well, that's the issue. So easy, here it is. The person is Kyle, working in that space. Of course, these are his grants that he's working on. I am assistant or associate. Associate. I think she's promoted just recently. Her work is also in that same space that I talked earlier, archiving, curation, data reuse. Okay, this is a common, again, please understand, for informaticians, for informatics folks, this is very important because we deal with data a lot, and no businesses or no industry probably ever worry about this kind of stuff. They just get data, they push to analytics, they push to results, and push to promote their business, selling their product. But their huge investment that they have made, data reuse, right? The biopharmaceutical world is discovering that now. They have trillions and trillions of data they collected over the last 20, 30 years sitting there, realizing, oh my gosh, we are reinventing. We could use some of this data to conduct our current research, instead of spending millions more. So this is applicable in any field. So it talks about some examples of where data reuse can be applicable. Sue Kim is, again, a system professor. She works in a different setting. She works with the socially marginalized groups through socio-technological interactions, primarily working in rural library settings, making it as an educational environment to address marginalized group, or we call the underserved, represented communities. That's her work focused on. Finally, we have an amazing center called the Polis Center. Have you heard about this? Okay. Polis Center is one of its kind in the country. Okay. It used to be located within the School of Liberal Arts, but a couple of months ago, 6 months ago, it moved into informatics. So they are now on the 4th floor where Marla used to be. Okay, if you visit the 4th floor once, that is where Polis is now sitting. We will have some signage and all see that. Polis is very unique. What they are doing is they are collecting community data, geographical data, geological data. They have built servers and services, and they work with the state agencies, FEMA, Red Cross, and all that kind of agencies, and they provide just-in-time information. Say, for example, there's a catastrophe here. Say there's a massive flooding. They have the data that the emergency folks need, where the flooding could happen, where it could spread in the next 2 minutes. These guys can provide all that immediately. Any kind of epidemic like COVID, for example, how is it impacting the underserved communities, right? We all know it has been affecting the underserved communities. This disappropriately, right? We all know that. They can provide you where, so that resources can be sent. That's what Police Center does. And it is about 34 years old center. And like I said, it's one of its kind in the country. They're very popular. They go around the country, do all kinds of consulting services and all that. So within this, they have different, they call it different programs or departments. The first one is community health informatics. These are the folks work in that area. They have, their focus is on precision health, population health, and public health. Now, this is, remember, we have a health informatics department. They're talking about the informatics side of things. These people are, this is all about data about community. Got it? Where in the community you give the zip code, they can tell what kind of health concerns in 46022 zip code area, what are the issues there? So they can do all that kind of stuff. So for example, United Way wanting to know something about, they want to do something in certain community or something. So they can consult with the police and where the needs are. So they can generate all kinds of visual and otherwise data on that. So they this is all about data and discovery or information generation for real clients. They have over 30 or so projects running all the time. Those are all funded by clients. These are funded by clients, whether it is state agency, federal agencies, others, United Way, people like that.
So as far as the people being funded, would they have, because when I think of funding, I think of the National Violence Foundation and how they have certain guidelines. So do these certain, the people that they're serving, do they require certain I guess rules and guidelines whenever they do receive grant money from them?
Yeah.
I know it's a kind of a weird question. But
So no. It's a
curious about
question. Is good. It's also important to know the difference. We, the faculty, we receive grants to do research. These people are, the police people are not doing that. They receive contracts. Okay, so contract means, for example, United Way will contact police and say, we need such and such data for such and such zip code with this kind of information. So police will say, okay, we have it, we need 2 weeks to generate that. And the cost of generating that information is going to be $100,000. So these people then, the people you're looking at, they will take that. Of course, the police has this humongous database that has everything in it, but you need to program the database, right? You need to build a query to streamline, generate the report, look at the report for the accuracy, and consult with the requester. This is what you want, and they put together a report and send it, and they get paid. So it's all contract. Almost all of them are contract. So they're not doing kind of research. That's why they joined us, because they think, police thinks that with the data they have and working with the SOIC faculty, they can go one step further from contract work to research work. At that time, we can go to NSF and get grant-like thingy, not contractual.
And Matthew, don't they run the Savvy?
Yeah.
So a lot of School of Education, we use that a lot for our research.
Excellent. Yep.
And use Savvy as a database for data specific to education and communities. We can put in zip codes.
Yep.
All kinds of things.
Exactly. Savvy is their database, actually. These are all coming from Savvy. So this is one talking about on this area. So you got it. What they're doing. And Savvy sit underneath all this, but these are, these are the kind of all kinds of queries that clients can generate and ask for data, right? And they can provide on those kind of things. in this particular case, their whole data is coming from Indiana Network Patient Care, because that's a public repository of health data. Your data, my data is all in there. Health, if you ever visited a hospital or a doctor, it's sitting in this IMPC. It's right there. So they get all this stuff from the data set here, and these are the various sources, and it's all linked. These guys take a lot of our students. I must emphasize this. Polis is a golden opportunity for SYC students and faculty, particularly for students, because what you're getting is an in-house internship opportunity, really, because you are working on real world problem, right? You're working on real data sets with a real problem from the community. Got it? Whether it is from government agencies or federal agencies, wherever it is coming from, you get to understand and you work on it, you develop things, and they're always looking for students to help. So that will translate. We have a lot of students right now working with the Polis as part of their coursework or independent study or projects or internship or whatever we want to call it. These are more details about their work. The other one is community informatics. Previous one was health informatics. Community informatics, most likely this is where Savi, LeJoy, this is what LeJoy was talking about. This is the Savi data. Savi is specifically the community database, okay? So it turns huge amount of raw data into meaningful community level information. So 70 data sources. This is the humongous database, and it creates so much information about the community. 13,000 community indicators, 25,000 community assets. So we're talking about anything from education level, with a fine detail in a grid. This is an interface. For example, they provide you a map of what you're looking. Where are the law houses? Where are the crimes in this region? You can ask any kind of questions. Where are the good schools in Marion County? Or developers can ask questions, or what are the flood regions? It's on and on and on. You can ask queries or ask for report, and these are all coming from the Savi database. Got it? So there is it's a lot of visualization, because the clients need something visual, not tables and tables of data, very visual. That's why they like our students. They want designers, people who have taken HCI classes. You will develop beautiful interfaces. That's particularly they are looking for. Help with the interface design, UX, UI, and at the same time, you are capable of working on interfaces, web app or native apps, that kind of stuff. These are all real shots from their interface. Yeah, recently they have become very advanced in showing things. This is a network of certain activity. Here is social issues, landscape of poverty, domestic violence, equity, social justice, school quality of choice, health food access. You see this? These are all coming from Savi. So there is always water quality. There's another one. So they didn't list everything. There are 25,000 determinants they can work on. So, in general, you get the idea. All right. So this data is constantly collected from 70 different sources, and the database is updated. So that's what Savi. Opportunities for students. Many grad and undergrad students contribute to our projects with the design, development, analysis, and more, gaining work experience. All right. When you get the experience, doesn't mean that you have to be in that space to work. It's data is data, right? So these are some of the students. These are our students. Community research and information infrastructure. This one is again the quality of life resiliency issues. It's more on the it's sort of coincide with the health informatics space or the health community. What is interesting, different here is the geoinformatics. This is the team within Polis. They work on a lot on geospatial data, right? You know, they use LiDAR. These are scanners, right? You attach this to drones and you scan the ground that can generate depth data on land. They use this a lot for understanding water flow. And from this water flow underneath the ground, they can predict flood or building. So developers need this kind of stuff, you know, where the soil is stable to build a 30-story building. You know, that what is the nature of that? This also helps a lot with the climate. Natural disaster, like I said earlier, if a hurricane or if it is a flood or something to happen in Indianapolis or in Indiana, they can predict all that, where the water is going to flow, right? So there's a lot of this is something they always show in every presentation. Construction, building codes, and resiliency, right? You know, they can predict these kind of things, the paths. This is a tornado or something touched down and taking away the buildings. Producing planting pattern. This is in agriculture. They can contribute a lot too. Where farming is proper and planting is appropriate based on this kind of data. This are all along that line, development, both in agriculture and also in housing. So, wow, that's amazing. Exactly 2 o'clock. I gave a lot of stuff, what's going on in our school, right? And probably this is like 70% or maybe 80% of all the work. There's still some folks in the MAS, like Zeb, Travis, and all those guys are doing some game work that is not in here. But otherwise, a lot on the informatics side of things, projects centered on programming, interface design, data analytics, data science, all that I have covered. And you get to know people.
Thank you, Matthew, for taking the time to go through that in such detail. And this session, part of it at least, was recorded when I remembered to push record. So I maybe missed like 2 or